Module 3, Lesson 9, Comparing Integers and Other Rational Numbers. So we are going to be continuing to making comparisons, greater thans and less thans. I can compare and interpret rational numbers' order on the number line, making statements that relate to the number's location on the number line to their order. And I already kind of started modeling this in the last lesson. I can relate integers and other rational numbers to real-world situations and problems. So we're going to create a real-world situation that relates to the numbers graphed on the number line. So go ahead and pause and think about a real-life situation that could be modeled with this situation. All right, so let's pretend that we're going on an 8-day, 40-mile hike. I know that's a really long hike, right? 8 days, 40 miles. So at the halfway point, which would be 20 miles into the hike, there is a check station for us to go check in and register and everybody make sure that we're okay. Now let's pretend we've got two different hikers, or two different groups of hikers. On Wednesday morning, we've got one group that has 10 miles to go before it reaches the check-in station, and we've got another group that is 5 miles beyond the check-in station. 0 on the number line represents the check-in station. So here, do a little erasing. So we have 0 is the check-in station where they're going to check on us. So on our number line, we have said what 0 is going to stand for. This is kind of an important concept. What is 0 standing for? What is it counting? At the halfway point, which is 20 miles, we've got the check-in station. We've got one group that has 10 miles to go before they reach the check-in station, which is right here. So they're not to the check-in station. They're 10 miles short of the check-in station. We have another group that is 5 miles past the check-in station. So looking at our dots here, we have 10 miles below the check-in station and we have 5 miles beyond the check-in station. Now, if you'll remember where I kind of started out by putting a 10 here and a 20 here. Now, the question is, when I put the 10 and 20 there, had I actually read the whole problem and paid attention to what 0 was going to be? And the answer is no. And so putting a 10 and a 20 here doesn't make sense, because that would mean that one group is 10 miles past the check-in station and another group is 20 miles past the check-in station. That's not really going to work. So it's important for us to pay attention to what is 0 going to be and what do we have in relation to 0. So here we are looking at exercise 1, and we're going to be doing the same kind of thing. We're going to create a real-world situation using the points. I've got a 0 and I've got a -1. We're going to describe the relationship between the values of the 2 points and how it relates to their order on the number line. Now, the first thing we need to do is we need to decide, what is 0 going to be? Well, let's pretend that we live someplace kind of cold, and we can say that we go out one night and the temperature is 0 degrees Fahrenheit. The temperature on Monday is 0 degrees Fahrenheit. Very cold. On Tuesday night, we go out and we check the temperature, and it's -1 degrees Fahrenheit. So the question we have here is, do I have a situation where I have modeled the relationship between the 2 points? So I have a comparison of 0 degrees Fahrenheit and negative 1 degrees Fahrenheit. I can say that Tuesday was 1 degree colder than Monday. So I've got a real-world situation and a temperature. I've used the numbers on the model. I have described the relationship. Tuesday is 1 degree colder than Monday. I can say on the number line that 0 degrees is warmer than negative 1 degrees. All right, so for each of these problems, we are going to determine if we agree or disagree with the representation, and we are going to defend our position, our stance, by citing specific details. So this will be a writing one, and I will probably do this verbally instead of trying to write it all down, because we would like this video to end sometime in the near future. So Felicia needs to write a story problem that relates to the order in which the numbers negative 6.5 and negative 10 are represented on a number line. Now the first thing I want to stop and do is say, on a number line, which one is left and which one is right? So I've got a number line. These are both negative numbers, and I would have 0. And I would have negative 6.5, and then I would have negative 10. The negative 10 is farther from 0 than the negative 6.5. Okay, so now that I have a picture in my head of how they look on a number line, I'm going to read this situation and see if I agree with what Felicia wrote. So during a recent football game, our team lost yards on 2 consecutive downs. We lost 6.5 yards on the first down. All right, that goes with the negative 6.5. During the second down, our quarterback was sacked for an additional 10-yard loss. Okay. On the number line, I represented this situation by first locating negative 6.5. I located the point by moving 6.5 units to the left of 0. Okay, so that's how they got to the negative 6.5. Then I graphed the second point by moving 10 units to the left of 0. Now, I'm going to agree that Felicia has negative 6.5 and negative 10 in the right spot on the number line. However, I don't think her situation matches these numbers. Because in the story that she wrote, in the situation she wrote, she said that they lost 6.5, which means on the next play they started here, and then they lost 10 more. So we should go to the 10 to the left of the 6.5. So she's got the numbers in the right spot, but these spots don't match her story. I think her story doesn't match her number line. Because it says that they lost 6.5 and then they lost 10 more. What they've got on the number line with negative 6.5 and negative 10 is that they lost 6.5 and then they went back to 0 again. And then they lost 10 more. Well, that's not exactly what happened in the story. They lost 6.5 and then they lost 10 more from where the 6.5 were. So really, she should have gone 10 from the 6.5. All right, looking at exercise 3. So we're going to decide if we agree or disagree, and we're going to use specific details to support our position. Manuel looks at a number line diagram that has the points negative 3/4 and negative half. Okay, give me a quick number line here. These are both negatives, so I've got my 0. I've got negative half, which is closer than negative 3/4. Okay. I borrowed 50 cents from my friend Lester. I borrowed 75 cents from my friend Calvin. I owe Lester less than I owe Calvin. So here's Lester, and here's Calvin. So Lester was 50 cents and Calvin is 75 cents. So I owe Lester less than I owe Calvin. So as I think about this, this is an agree, but there's part of me that feels like we need to explain this a little bit. So we've got a negative 75 hundredths. If we turn that, let me try a little bit better job there. So negative 75 hundredths, that's what that negative 3/4 is. And we've got a negative 50 cents. That's what that negative half is. And it's true that owing Lester 50 cents is less than owing Calvin 75 cents. That's true. That is absolutely true. However, when I look at it on the number line, this negative 1/2 is actually greater than the negative 3/4. So the way that the situation is right is in real life 75 cents is more, but if we're just looking at the values, we would say that 50 hundredths is greater than 75 hundredths. So kind of a tricky one there. All right, so we've got Henry who's locating 2 1/4 and 2 1/10 on a number line. So I've got my number line, and I've got 0, and I've got 2 1/4, which is 2 25 hundredths, and I've got 2 1/10. Okay. And he wrote the following story. In gym class, both Jerry and I ran for 20 minutes. Jerry ran 2 1/4 miles, and I ran 2 1/10 miles. I ran a farther distance. So think about this here for a second. So we've got 0 and we're moving to the right and we're measuring which one of these is a farther distance. Well, if they both started at 0, who ran farther? Well, 2 25 hundredths is farther to run than 2 1/10. So I think I'm going to have to disagree. I think that Jerry ran farther because 2 25 hundredths is going to take us farther than 2 1/10. All right, looking at exercise 5. So Sam looked at 2 points that were graphed on a vertical number line. He saw the points -2 and 1 5/10. Okay, vertical number line. And I've got -2, and I've got a positive 1 5/10. Okay. I'm looking at a vertical number line that shows the location of 2 specific points. The first point is a negative number, so it is below 0. The second point is a positive number, so it is above 0. The negative number is -2. The positive number is 1/2 unit more than the negative number. I loved everything about this except for here. To get from -2 to 0, I've got to go 1 unit, 2 units, then I've got to go another unit to get to 1, and then I've got to go 1/2 of a unit more. I don't think the positive number is a 1/2 unit more than the negative number. I think it's 1, 2, 3, and 1/2 more. So I think I'm going to have to disagree with this statement. All right, looking at exercise 6. Claire draws a vertical number line. We've got 2 points, -10 and 10. Okay, and we've got the following story. These 2 locations represent different elevations. One location is 10 feet above sea level. Okay, that would be this one, 10 feet above sea level. And one is 10 feet below sea level. Okay, that's 10 feet below sea level. On a number line, 10 feet above sea level is represented by graphing a point at 10. And 10 feet below sea level is represented by graphing a point at negative 10. Well, what do you think there? I'm agreeing. If 0 is sea level, then this would be 10 feet above, and this would be 10 feet below. All right, exercise 7. Mrs. Kimball, the 6th grade math teacher, asked the class to describe the relationship between 2 points on the number line, 7 and 45 hundredths and 7 and 5 tenths, and to create a real-world scenario. Jackson writes the following story. Well, I'm going to get my number line here and take a quick look here. I've got both greater than 0, so 7 and 45 hundredths and 7 and 5 tenths. Okay. Two friends, Jackie and Jenny, each brought money to the fair. Jackie brought more than Jenny. Okay, there's a claim there. Jackie brought $7.45 and Jenny brought $7.50. Now looking at my number line, I'm a little bit concerned here. Claiming that Jackie brought more, but Jackie brought $7.45, and when I look at my number line, $7.45 is less than 7 and 5 tenths. So let's look at the thinking here. So Jackson says since 7 and 45 hundredths has more digits than 7 and 5 tenths, it would come after 7 and 5 tenths on the number line, or to the right. So it is a greater value. What is your thinking? Do you agree or disagree? Well, we've already looked at the number line, and we know that 7 and 5 tenths is coming to the right. So I'm going to have to disagree. And on top of that, I'm really concerned about what Jackson is thinking. Jackson is thinking in terms of whole numbers, 1, 10, 200. When you have more digits and you have a positive whole number, more digits makes greater. But when you start dealing with fractions, more digits doesn't mean bigger number. If we compare the 7s, they're the same, but this only has 4 tenths and this has 5 tenths. So really, Jenny brought more than Jackie did. All right, looking at exercise 8. Justine graphs the points associated with the following numbers on a vertical number line. Okay, quick little vertical number line here. I've got negatives and positive. I've got a positive 1, gets to be by itself. I've got a negative 1 1/4. And I've got a negative 1 1/2. The nurse measured the height of 3 6th grade students and compared their heights to the height of a typical 6th grader. Okay, now I just heard there that 0 is a typical 6th grader. So we are taking some measurement and we are adding and subtracting from that measurement, and that measurement is not 0. Maybe it's 50 inches and we're adding an inch, taking away an inch and a quarter, taking away an inch and a half. 2 of the students' heights are below the typical height. Okay, so 0 is typical. I have 2 that are below. The point whose coordinate is 1 represents the student who has a height that is 1 inch above the typical height. Okay, I agree with that. Given this information, Justine determined that the student represented by the point associated with negative 1 1/4 is the shortest of the 3 students. I have a problem with this one right here because we put it on the number line and we said 0 is the typical 6th grader height. And then we subtracted 1 1/4, and then we subtracted even more to get to negative 1 1/2. So the shortest of the 3 students is the one that has the number negative 1 1/2. Because it is the farthest away in the negative direction from the typical 6th grade height. All right, so how can we use the number line to order a set of numbers? Will graphing the numbers on a vertical number line rather than a horizontal number line change this process? Well, looking at this second part here, vertical number line, horizontal number line, we did them both in this lesson, and it didn't change the process. We're still ordering the numbers from least to greatest, greatest to least. So we can create and locate the numbers on the number line to determine their order. If we use a vertical number line, their order is the same as on a horizontal number line, but instead of moving from left to right, from least to greatest, you move from bottom to top, least to greatest. To determine the order of a set of numbers, the number that is farthest left or farthest down on a vertical number line is the smallest value. As you move to the right or toward the top, the numbers increase in value. So the greatest number is graphed farthest to the right on a number line, or the highest one on a vertical number line. So if 2 points are graphed on a number line, what can you say about the value of the number associated with the point on the right in comparison to the value of the number associated with the point on the left? So we're tying it to value now. The number associated with the point on the right is greater than the number associated with the point on the left. As we move to the right, we have greater value. Keep hitting that over and over again. So which number is larger, 3 4/10 or 3 1/2? And how would graphing these numbers on a number line help you figure this out, make this determination? Well, let's quickly create out a number line here. They're both negative, so I'll put 0 off here to the right. Now I'm going to -3 with both of them. So -1, -2, and -3. Now it would be really useful if these were both in the same form. So I've got this -3 4/10, and I've got this -3 1/2 is 3 5/10. Things we've worked on in Module 2. So I can cut it or split it into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be where 4/10 is, -3 4/10. And then this would be where -3 5/10 would be. So which one is to the farther left or farther left of 0? Well, that's the 3 5/10. So if we're asking which one is greater, we would be looking at the 3 4/10 because it's closer to the 0 heading this direction. This is farther to the left, therefore it is less. So whichever number is graphed farthest to the left is the smaller number. So in this example, -3 1/2 would be graphed to the left of -3 4/10, so it's the smaller number. You can compare the numbers to make sure they are graphed correctly by either representing them both as a decimal or both as a fraction. It's easier to compare if they're in the same form. -3 1/2 is halfway between -3 and -4. So if I divide the space into tenths, the associated point would be at -3 5/10, since -3 1/2 is equal to -3 5/10. And when I graph 3 4/10, it'd be 1/10 closer to the -3. So it would be the right of -3 1/2. Which means that 3 4/10 is larger than -3 1/2. -3 4/10 is larger than -3 1/2. All right, so here we are, end of the lesson. I can compare and interpret rational numbers' order on the number line, making statements that relate the number's location on the number line to their order. I can relate integers and other rational numbers to real-world situations and problems. And I hope you remember that some of this has to do with the situation that you create. I keep going back in my head and thinking about that problem clear up here. Let's see, not that one. This one with the money. There's two different ways to look at this one, and we have to apply it to the situation. So owing Lester less than is owed to Calvin. Well, they both are owed money. One of them is owed 50 cents and one of them is owed 75 cents. Well, this number right here is owing someone less. So I agree with this statement. I owe Lester less than I owe Calvin. However, if we look at the number line, and if we were putting these numbers just in order from least to greatest on the number line, we would say that 75 hundredths is less than 50 cents. But the real life situation is you want to owe someone less money. So once again, I don't want to confuse things too much, but we do need to think about the context of these numbers, the story that goes with them. All right, so that concludes Module 3, Lesson 9. Make sure that you complete your problem set and your exercises. If you've got, let's see, problem set and exit ticket, and if you've got questions, make sure that you talk with your teacher.